All right, so for 8.1, function operations, we're going to find the sum, the difference, the product, and the quotient of functions over the next couple days, and find the composition of functions. All right, so first up, if we look at this table, okay, it kind of tells us all of our function operations. So if we have addition, if we see f plus g of x, so that means we're adding two functions together, okay? It's just saying we're going to do f of x plus g of x. Usually those are two different equations. Okay, so f of x might be 2x plus 1, where g of x might equal 3x plus x minus 5. Okay, so this is telling us how to combine them. If it's addition, then it's f of x plus g of x. If it's subtraction, so f minus g of x, we're going to find the f of x and subtract the g of x value. Okay, order matters because you can also have like g minus f of x. Okay, so order totally matters. Multiplication, if we have fg of x, we're going to take the f of x, solve it, multiply times the g of x. And if it's division, f over g of x, then we're going to find the f of x divided by the g of x. But there also has to be this notation, okay, in a division problem, like x can't equal 0 in this case. So we're going to look at some of those. Questions so far? I know we're going to kind of put a lot out there. Okay, so functions, it says, are excellent tools for creating models in science, engineering, technology, and economics. So the sum, difference, product, and quotient of functions are defined by those function operations we just looked at. The domain, because we're going to look at some of those as well in the next few days. The domain of the resulting function is the intersection of the domains of the two functions. So it's where they intersect. Okay. The resulting function may also be limited by the fact that division by 0 is undefined. So this is a limit. Okay, that's what that's talking about here. We put a limit on it because it can't be 0, otherwise our answer would be undefined. Or if our denominator was x minus 2, what can x not equal here? 2. Why? Because it would be a 0, right? If we had a denominator of 2 minus 2, it would give us a denominator of 0, which is not possible. It would be undefined. We can do 0 divided by a number. No. I was setting up a fraction. Like this was 6. Like I was just looking at the denominator part. Sorry. So yeah, if we had a fraction and we had this in there, we would have to say, oh, there's a limit to this one. Okay. Okay, then functions can be thought of as machines, where each machine performs a specific function. Have you guys ever heard of that before? Like functions as a machine? You put one number in and you get another number out, or maybe they call it an input-output machine. Ever heard that? It's called a calculator. It's true. It is true. It's like a calculator. All right. So, but a lot of times in like middle school when you're learning about functions, that's what they tell you is they're like a machine. Okay, so the addition of two functions can be illustrated as the sum of the outputs of two different function machines. So if like we look here, this is function f, right? This is f of x, and this is function g. Okay, so the addition of two functions is strictly where you take the output of one and what you got out of the other machine and you add them together. It's like if you work two jobs and you get paid $50 at job A and you get paid $25 at job B, and you say you add them together to find out how much money you made total. I hope not. 50 and 25? His math is off today. Okay. There. All right. There you go. So an operation with two functions can be written as one equivalent function. That's what we're going to do. That's our goal, is like figuring out how to write these as one equivalent function. okay, and how to combine them to do that. So let's get started on the actual work part. Okay, so example 1, we've got an equation for f of x. Okay, so f of x equals the quantity of x plus 1 squared. And we have a value for g of x, or an equation. G of x equals x minus 2. So we want to write the function rule representing the result of each function. So we want to write one rule. Okay? Not walk away. Charge ahead, right? You're like Roman soldiers in a legion together. I'm carrying the standard. It's time to move forward. We are not retreating. Okay. All right, so it says f plus g of x. So what are we going to do to these two functions? We're going to add them together. Okay, so first of all, this is just the same thing, remember, as f of x plus the g of x. So what's...
This is what we're doing with like that operation. So just the totals of each of them.
Well, we don't have, so here's the difference. Like, we're not quite getting a final number because we don't have a number to plug in. We're simplifying these two equations. We're putting them together and simplifying them into one. It is not already like that. So, like, what is f of x? It's x plus 1 squared. Okay, so this is x plus 1 squared is f of x. Plus, what's my g of x value? X minus 2. Okay. So the first one we're going to have to FOIL because it has an exponent. Okay, so what's... Well, because it's saying the quantity x plus 1 times the quantity x plus 1. Right? That's what that square means. So I have to FOIL them to find it. It's not what? Right, but I don't have a number. There are no numbers. It won't mess up my answer because we know the way around that. The workaround to not having a number is to FOIL it when we have a binomial. We will, and I'll prove it to you. So let's FOIL it first, and then I'll prove it to you. We'll make up a random number. Okay, so we have x squared plus what? X plus x plus, okay? So we've got x squared plus 2x plus 1. Then we've got to bring down the addition up here. So plus x minus 2. Right, that we didn't do anything with yet. It's got to come down. Now, do we have any like terms that we can combine? Yes, we do.
Add the x and then subtract the 2.
Okay, so the 2x and the x will go together. So I'm going to have x squared. What's 2x plus x? Plus 3x. And then minus 1, because I can do the 1 and the positive 1 and the negative 2. All right, so this is my new function rule. Might call it a composite even. Okay, now going back to what Brandon said, we wouldn't get the same thing. Let's say x equals 7. Okay. All right, so I'm going to pick it up from right here. So if we have 7 plus 1 squared plus 7, because I'm putting it in for my x, minus 2. And I'm going to put 7 in down here. So I'm going to have 7 squared plus 3 times 7. I should have had 7 times 3. No, that's right. 3 times 7 minus 1. Okay. So 7 plus 1 squared is 64 because it's 8. Okay, so then we have, let's go ahead and do 7 minus 2. 64 plus 5, 69. All right, 7 squared is 49 plus 3 times 7 is 21 minus 1. So 21 minus 1 is 20. 49 plus 20 is Do you like my mic drop? So foiling is the workaround. When we don't have a value to plug in for the variable, we can keep working and simplifying and getting one equation together. Okay. Do you believe me now, Brandon? Even though you don't want to, right?
But I was saying, like, if just, like, the x plus 1 squared, if you're just trying to do that and you did that, you couldn't find the same answer.
He's saying.
Well, you could, but you would have to put it, I see what you're saying. Okay, but you would have to put it into this piece, the part that was, so same thing there. So that was 64, right? X plus 1 squared, if we put the 7 in, it was 64. If we put the same thing here, 7 squared is 49, plus 2 times 7 is 14, plus 1. Okay, so this was 64. All right, 49 plus 1 is what? 50. 50 plus 14 is 64. It depends on where you're putting it, but like we foiled this and we simplified it to this point. So yes, if we put it in, if we do just compare just this piece to where we foil it, we do still get the same answer. Or if we plug the number into the whole thing, the whole problem in both places, we still get the same answer because we've learned workarounds for when we don't know the value of the variable. Okay. So then let's try B, which is subtraction. Okay. So we've got, this time we're going to take the f of x and we're going to subtract the g of x. Okay, so the nice thing is we've already done some of the work here. So like, what do you want to put in for f of x at this point?
X plus 1, or no, x squared plus x. No, x squared plus 2x.
Yeah, I would go ahead and put this piece in.
Following it down and kept
Right.
simplifying.
Because we've already done all the work to get it. Yeah. Simplified. So x squared plus 2x minus 1. Oh, plus 1, pardon me. No, it is plus 1 here. Right, because that's where we've simplified this piece. Okay. Then it's minus all of the g of x. So I'm going to put, I mean, I could have put parentheses in here. I didn't because it was addition, but because it's subtraction, yeah, because that sign is going to have to be changed eventually. Okay. So minus the x minus 2. Okay, so then that would be, if I go ahead and change my sign, x squared plus 2x plus 1 minus x plus 2. And then we're ready to combine like terms. So we don't have any other x squareds. What about 2x minus x? That'd be x. And then we have 1 plus 2. And that is your function rule, x squared plus x plus 3. Instead of having all these random parts. All right, so for C, when we have fg of x, we're going to take f of x, and we're going to multiply it by g of x. Again, we've already simplified the work for f of x to get us to this x squared, so I would put that in so you don't have to do it again. So x squared plus 2x plus 1. Well, I've already, because you would have had to have foiled.
No, but I mean,
Oh.
like, in this next step.
Yes. And then the next step, so then our g of x is the x minus 2. And then, yes, we have to FOIL. So x squared times x is x cubed. X squared times negative 2 minus 2x squared. Okay, let me change that. Then I'm going to do 2x times x plus 2x squared. And 2x times negative 2.
Minus 4x.
So you just completely ignore the extra.
The 1?
You just completely ignore it.
No, I'm going to do it next. I'm taking this one, the x squared, and distributing it to both the x and the -2. And then the 2x distribute or FOIL to both.
Doesn't matter how many things you have, you can still FOIL.
Okay, and then the last one, so 1 times x is x, and 1 times -2 is -2. Okay. So yep, so as long as you, you take each part in the first part and distribute it to every part in the last one, then you're set. Okay, so now we need to combine like terms. So there's only 1x cubed. Okay. The next one's cancel, right? We have a -2x squared and a positive 2x squared. Okay. -4x plus x is -3x and -2. But this is a whole lot easier to work with, like once you have numbers, especially if you have to graph it and you have to plug in like 5 or 6 numbers. You don't really want to plug the number in way up here. It'd be easier to solve this one time and then quickly plug your numbers in. Seems like more work to start with, but not necessarily. All right, then D, we're going to have f of x divided by g of x. Okay. This one may be better not to use our simplified form, right? Because we want common things, right? Common. Okay. So if we leave it as x plus 1 squared over x plus 2, minus 2. I was like, after I said it, I knew I was wrong. If it would release. Okay. Or you might say, you could also say, okay, well, this is x plus 1 times x plus 1 over x minus 2. Just so you can see like all the different components. Does anything in the numerator match anything in the denominator? To cancel. Like, do any of those binomials match? No, it has to be a whole binomial, like the quantity x plus 1 and the quantity x minus 2. Sometimes that's why we put parentheses around them to remind you, like, okay, do any of these things in parentheses match? They're not the same. So this one we can't simplify. Okay, because there is no match. Or no like terms is what we should say. Because like if we have 6x over 12, the 6 and the 12, right, cancel. They both have a 6 in common. So we would be able to change them to be, oh, this is the same as 1x over 2. But we have to have a commonality to cancel to actually be able to divide. Okay, same thing when we had x to the third divided by x. Okay, well, 1x would cancel, right? This one has 3 x's, this one only has 1. So this one would cancel out, and this would change to a 2. So we'd have x squared. We have to have like terms or commonalities to cancel. And because we don't have any here, then we can't cancel or simplify or do anything else. But we can limit it. What's the limit to this one? X cannot equal 0. Or it cannot equal 2. It's not always, I mean, it can't be total of 0. So it would be 2 in this case. So we can add a limit to it, but that's the best we can do on D, is add a limit. All right, questions so far? Okay, then we're going to get into some composition of two functions, f and g, which is denoted f of g. Okay, it's the same thing, we're still reading it. F of g is defined as f of g of x, or f of g of x. It doesn't matter how you read it or how they write it, it's always f of g of x. Or again, we can have it the other way. It can be g of f of x. It could be h of g of x, right? It's just different ways to write functions that go together. All right. So expressing f of g of x as f parentheses g parentheses x. Notice, Lauren, I need you to whisper, please. Okay, we're going to have one set of parentheses around our x. And then we're saying, okay, this is the g of x. Okay, so it kind of goes from the innermost to the outermost. But this is helpful when we're evaluating a composition of functions for a given value of x, because we first evaluate the inner function. Okay, Lauren, whisper. Okay, and then we use the resulting value to evaluate f of x, which may not make any sense just yet. So let me show you. On this first one, so f of g of x is the same thing as f of g, let me change it up, of x. It is a degree sign because we call it f of g of x. So what is helpful for me to think about is I'm going to take my f of x. Okay, f of x equals x squared minus 3. Are we good with that? But what this is saying is I don't have f of x, I have f of g of x. So anywhere I have x, I'm going to put my g of x in there.
So if there's an x, it's 2x plus 1 squared.
Okay, so it's going to be, so my x is to the quantity 2x plus 1 squared minus 3. Because that's what this set up here. It was x squared. Yep. Oh, no, that's not right. Okay. So this is, so it's like a long, I mean, like this looks very short, but it's actually like a paragraph. Okay, because it's saying I'm going to solve the function of f, like I'm going to solve function f, but okay, I'm actually going to solve function g, put g inside that, and solve it. So it'd be no different than if we knew a value of x, say x equaled 5. Okay, so if x is 5, we could say, this is multiplication, we could say, all right, well 5 squared is 25 minus 3. So that'd be 22 for f of x. G of x, 2 times 5 is 10, 10 plus 1 is 11. And then we would multiply f of g of x, just means I multiply those together. So I would do 22 times 11. But again, because I don't have a value for x. What? No, that's not what the negative 2 is. I am going to have that in just a second, but I have to figure out how to set it up first.
But my question is, if you're doing the exact same thing as you did on the other page, why is it written down?
It's not the same though. That's what we're doing on this side.
So the other side was adding, subtracting, multiplying, and dividing.
But you're just multiplying. Why is it written down?
Because there are different ways to write them. Like there's different notations.
But you're doing the exact same thing.
You are, yes, as the multiplication one. So we did 4 on the other page. We did 1 addition, 1 subtraction, 1 multiplication, 1 division. So this is exactly like the multiplication one.
Then why does it look
It isn't though.
different? Yeah. If it's the
Oh, I'm sorry. No, this is because the other one was f times g of x. This one is saying f of x.
Isn't that what you just did up there though? When you plugged 5 into both of those? Multiplied them? Because you put 5 in for x, so if 5 squared is 10 minus 3, then you wrote that number up there, and you put 2 times 5
Right.
plus 1, and then you just multiplied those two together. So that's what we were doing on the other page, but then
So no, that's what we were doing on the other page. Yes. I was showing you what we did on the other page, not what we did here. Yes. So we're taking, I'm trying to think of a better example. Okay, I was like, so let's see. So then do we have it all set up here? 2x plus 1 squared minus 3. Okay, so we don't have to work this out anymore. Once we have it set up where we have the g of x inside, right? The g of x is inside the f of x function. Just like here, the g of x is inside the f of x function. Now that we have that, we can use the -2 and say, okay, well, we're going to do f of -2. Pardon me. Let me go back. We're going to do f of g of -2. So now we're going to take this part up here and we're going to plug the -2 in for it. So we're going to have 2 times -2 plus 1 squared minus 3. So what's 2 times -2? -4. What's -4 plus 1? All right, so I'm going to go ahead and say, okay, this is -3 squared minus 3. So what's -3 squared? 9. What's 9 minus 3? So the f of g of -2 equals 6. So yes, I apologize because what I was showing you earlier was the same thing we did on the back, and this is not the same. Because this is, we're taking the answer, whatever the answer is for this one, and we're plugging it in as the x for, like, as the value that we're putting in for x for the next one.
So it's a shortened way of having a number of g of x, taking the g of x equals and putting that number of f of x.
Yes.
Doing all of that work
Yes.
at the same time.
Yes. So like because so like it talks about at the beginning, right? We can use these to create models in science, engineering, technology, economics. So if you're looking at economics and so say, I don't know, maybe you run a business where the number of things that you like, so like say of g of x, I'm trying to think of something you could have. The number of, let's say, games that you sell on your Amazon store or something. The number of games that you sell needs to like, or like so you can put in x first, which is like the number of games that you sell. Okay, and if you put it in the g of x equation, it's going to tell you the amount of money like that you're generating. Okay, but then once you find that number, you have to put it into the other equation to find out what the like cost analysis is, like what the actual cost of all of that is. Right. Okay, so instead of doing that in multiple steps, this is the way you can do it in one step and find that final thing. So typically, you know, like when you're getting into this, you would write the function, and then you would have a computer program that would be set up to calculate it for you all the time. So you could input numbers in a table, like in Excel, right? We write formulas in Excel. But once you know how to write the formula, you can write the formulas and then just input numbers in a table and it'll do all the calculations for you, is ideally the goal. But how do we write the formula? Is kind of the thing. Okay, so in B, we're doing f of g of 3 this time. F of g of x, f of g of 3. So is this part any different? No, you've already done the work for that. So it's this same formula, like we've already done all the work, we can just transfer it over and say, okay, well, we're going to be using f of g of x equals the 2x plus the quantity 2x plus 1 squared minus 3. The only thing that changes this time is that we have the 3. So this is going to be 2 times 3 plus 1 squared minus 3. So what's 2 times 3? Plus 1. 7. What's 7 squared? 49 minus 3. 46. So this time it's equal to 46. All right, so your homework is 1 through 17. Odd, you're not going to be able to get through all those where we stopped today.